Hi, Shana. Good evening.
I'm actually sending it later. I thought I sent it, but I didn't.
Can you hear me, Shana?
Yeah, I can hear you. Can you hear me?
Okay. I think my audio is low. I just changed my speaker. Can you hear me now?
Yeah.
How are you doing?
Good. How are you?
I'm good. Thank you. Just a second, Shana. Just share my screen. So you said you have doubt in the question number 19, 23, 24, and 25. All right.
Yeah.
So I hope you're able to see the question number 19.
Yeah.
Okay. Could you please read out the question for me?
A total of n points are equally spaced around a circle and are labeled with the integers 1 to n in order. 2 points are called diametrically opposite if the line segment joining them is the diameter of a circle. If the points labeled 7 and 35 are diametrically opposite, then n equals.
Okay. So let's understand this diagram. Let's understand this question diagrammatically first. I'll just draw the diagram for this. So they said it is a circle. They also said it is equally spaced around the circle. So if we could imagine an example, you can imagine about the clock, right?
Yeah.
The clock is in a circle shape. It is also equally spaced, right? Like 12, 1, 2. It goes on like that. But here they are saying that labeled with the integer 1 to n, which means like we'll assume you're starting this as 1, like 2, 3, 4, 5, like that. It goes on up to n, right? Okay, let's draw the diagram for the clock itself.
Yeah.
That might be easy to interpret it. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. So equally spaced around the circle and labeled with the integer 1 to n in order. So you just imagine you don't have the endpoint as 12, it goes up to n. Okay.
Yeah.
And they're saying that 2 points are called diametrically opposite if the line segment joining them is the diameter of the circle. For example, you can call this as the diameter of the circle, right? And also we can say this one is the diameter of the circle. You try to join any opposite, maybe from the 0.983, if you're going from 4, it should connect the 10, right? If you're starting
Yeah.
from 5, it goes to 11. It goes on like that. If the
So
points labeled 7 and 35 are diametrically opposite, like assume you have 7 here and 35 is diametrically opposite to the 7. They're asking us to calculate the number of points in the circle.
yeah.
Okay, let's look at the solution once. Okay, so they're saying that the number of points on the circle equals the number of spaces between the points around the circle. Okay, I'll give you a formula for this. This might be helpful for finding the total number of points. We can derive this formula from the clock. Like we can say right side points plus left side points.
That's what.
And
Then for some reason I got it wrong. I don't know how.
directly opposite. Yes, Shana, what you were saying? For some reason?
I did the same thing. Like I added from 7 to 35 how many, and then like the opposite way, and then I
Okay,
added 2, but I don't know, it didn't work somehow.
okay. Actually, like here, the hidden concept is, the clock. If you are able to apply this logic, then you might be able to figure this out.
Yeah.
I will just show you like how I derived this formula from the clock. Like they said, like the total number of points can be right side points, left side points, and the directly opposite points. If you take the example of the clock, the total number of points in the clock must be 12, which means you have to get the answer as 12, isn't it? And also they said that they are directly opposite to each other. So if you take these two, the 12 and 6, if you check their differences, you're gonna have like 1, 2, 3, 4, 5 points, isn't it? The right side.
You're also gonna have that one.
And on the other side, you do have 1, 2, 3, 4, 5 points, right? This is for the left side. And you have directly opposite points, 2 points. So if you add all of them, you're going to have like 5 plus 5 plus 2. For example, for finding the right hand side, I got the answer as 5. If I subtract these two endpoints, I'll get the answer as 6. And I do have to subtract 1 from this for obtaining the value as 5, isn't it? So you can derive the formula for the right side as the number of points on the right side is equal to the difference of directly opposite points, opposite points minus 1, right? 12 minus 6 minus 1. You'll be able to get the answer for the right side. And similarly, you can use the same formula for the LHS as well. You're going to get 12 minus 6 minus 1, which will give you the answer as 5. And for directly opposite points, you can just directly count the 12 and 6. It works like that. So you can apply the same logic over here as well for calculating the points from 1 to n. And here they said, like here in the clock example, I took the example as 12 and 6. And here we do have 7 and 35. I hope you are able to follow this now. So you just have to subtract 35 and 7 for finding the in-between points. If you place 35 here and 7 here, you would be able to calculate all the right-hand side point by subtracting 35 and 7. Do you understand this? Do you understand this part, Shana?
Yeah. Yeah, I get it.
Okay, I think your voice is pretty low. I'm not able to.
I don't
Okay, yeah, now it's fine.
know. Okay.
So similarly, for obtaining the value of the left side, you're just going to get the other half, right? Which is going to be 28 spaces. So 28 and 28 will give you the answer as 56, right? And here the question is about the spaces. So you can ignore the directly opposite points. You can just calculate the right side and left side points alone, which will give you the result as 56. Let's go back to the question once and we'll verify our results. If the points labeled 7 and 35 are diametrically opposite, then n equals. Wait a minute. In such case, I might be getting the result as 58 as well. I do have option. 1 minute, Shana. I'll just verify this. I didn't have much time to go through this question earlier. The question is to find the total number of points, right? Because the total points is n. It's not about the space, okay. -35 -7 will give you 28 only, right?
Oh, I know. Since like you're subtracting the two, so like 35 and 7, when you subtract, you're counting, you're including 7. So when you double it, you're including 7. So then when you add 2 times, you're including 35 the second time. So then you don't need to add the extra 2 because it's already there. We never counted the points in between 7 and 35.
Oh, yeah. Yes. We didn't exactly draw the points between 7 and 35, isn't it?
Yeah, that would be 27 instead
Yes.
of
Yes.
20, but
You're
instead
right.
we counted this one.
Yes. We have included this as well. Thank you. Good. Yes, so the solution is 56.
Yeah, I think that's where I went wrong. I think I counted it again extra, like the extra 2.
Okay, you also got the answer as 58.
Yeah.
Okay. Of course, like I didn't depict this 7 to 35 thing in the clock, right? Okay, so we'll move on to the next question. Question number 23. Suppose that PQRSTUVW is a regular octagon. A regular octagon is an octagon with 8 equal side lengths and 8 equal interior angles. There are 70 ways in which 4 of its sides can be chosen at random. If 4 of its sides are chosen at random, and each of the sides is extended infinitely in both directions, what is the probability that they will meet to form a quadrilateral that contains the octagon?
Yeah.
Actually, I went through the diagram. The diagram part was pretty clear. Question number 23. Yeah. I think I don't have to draw the octagon diagram. You know how to draw octagon, right? Like 1, 2, 3, 4, 5, 6, 7, 8 sides. So in the question, I'll just open the question in my mobile phone. Please give me a second. Oh yeah. Okay. So in the question, they are saying that you are choosing 4 sides and also you are extending them infinitely in both the directions. Let's assume this is the case 1 or figure 1. So you're going to choose 4 sides. If you choose these 4 sides, just all the adjacent sides together, if you do chosen this, you do have to extend their sides, which means let's assume this one is side 1. You're going to extend this side in both the directions. Like you are extending infinitely, right? That's what they're trying to say. And if you
Yeah.
choose this side, this is also getting extended. And if you choose this one, this is also getting extended. I hope you are able to follow the concept. So if you choose this side, this gets extended, both the sides. The thing is, you have to check after the extension whether they'll meet to form a quadrilateral or not. This is not a quadrilateral. This is
Yeah.
not a quadrilateral, right? So this is not possible. Figure 1 is not possible. So they are going for figure 2. What if you choose like 3 adjacent sides and you're picking the 4th adjacent and you're going for the 5th one? Okay. Again, you're trying to extend all the sides. You're just observing the results, whether you are obtaining the quadrilateral or not. You're not getting it. So now you're choosing 2 adjacent sides on the left and 2 adjacent sides on the right. You just leave the top and see whether you're able to create a quadrilateral. No, still this side is open, right? It is not possible. So you are repeating the same, like if you choose the figure 4, like S1, S2, S1, S2 like this. Okay, we'll just go through the theory as well. Like we can come back to this later. Like, okay, we'll just go through all the figures. Okay, that might be easy. So if you
Okay. Yeah.
choose like S1 and S2, and also like, S1 from here and S2 from here, you are getting a triangle, right? And if you choose this like S1, S2, S3, S4, this results in a quadrilateral. I hope you are able to follow this. These extensions will form a quadrilateral. Do you understand this? Do you understand this part, Shana?
Yeah.
All right. So now we know like how to achieve the quadrilateral.
Yeah.
Uh, in the question they're saying that there are 70 ways in which 4 of the sides can be chosen at random. They're asking about the probability of obtaining the quadrilateral contains the octagon. And also, like inside, you should have an octagon. Okay,
Yeah.
that's the question. which means, uh, okay, we'll proceed figure by figure. We'll go to the figure 1. I hope you understood the figure 1, right? If the four
Yeah.
sides that are chosen are adjacent, the very next sides, then when these four sides are extended, they will not form a quadrilateral that encloses the octagon. Yes, it is not enclosing the octagon. This side is still open. And again, like you are going for three adjacent sides and you're not choosing the other side and you're going for the fifth one, still you're not able to form this one. That's what they said in the figure 2 and figure 3. So from this, they are concluding any other set of four sides that are chosen will form a quadrilateral that encloses the octagon. This is true based on the following argument. Okay, let's see. Suppose that side S1 is chosen, that S2 is the next side chosen in a clockwise direction. So they are calling this one as the clockwise direction. Okay. These two sides will either be adjacent or have one unchosen side between them, like this. Or you do have two unchosen sides in between them. Can you follow this? They're saying that they cannot have three or four adjacent unchosen sides between them from the previous argument, because if you look at the figure 1, they didn't choose four sides, they couldn't get the result. And here also they couldn't choose three consecutive, which means like three adjacent sides, they didn't get the result. And here also they couldn't get the results in, they couldn't choose these three sides, they do have three unchosen sides, they're not getting the results, right? So they're just trying, what if you choose two sides will either be adjacent, and what if you choose you have one, only one unchosen side between, and or two unchosen sides in between. Can you follow this? So you are creating these three categories. So now they are just going to combine the results. So they are just going to extend their sides and let's see whether we would be able to create a quadrilateral or not. So I hope here you will be able to see like one unchosen side, and here you will be able to notice two unchosen side, right? And here you do have two adjacent sides chosen. They just combine the figure 4, 5 and 6 for obtaining the result as figure 7. Do you understand this part, Shana?
Yeah, I am okay.
All right. Okay, so they're coming back to the question again. We are told that there is a total of 70 ways in which four sides can be chosen. This statement is already given in the question. We will count the number of ways in which four sides can be chosen that do not result in the desired quadrilateral and subtract this from 70 to determine the number of ways in which the desired quadrilateral does result. This we do this in the probability. Remember, for finding the probability of A bar, you just have to subtract this probability of A from 1. Do you remember? For finding the probability of the failure, you just have to subtract the success event from the 100. Can you follow this, Shana?
Yeah.
For example, like in the probability, if they're asking, like assume a situation like an urn contain the three red ball and three black ball. If they're asking you to find the, just give me a second, give me the baby's name. If they're asking you to choose, find the probability of not choosing the red ball, means you will obviously find the result for choosing the black ball, isn't it? You are applying the same strategy here. So you are just going to subtract the do not result from the 70. I hope you are able to follow this. Okay. There are 8 ways in which to choose 4 adjacent sides. Choose one side to start. There are 8 ways to choose one side. And then choose the next 3 adjacent sides in clockwise order. There is one way to do this. Can you follow this statement?
Yeah.
Could you explain what that means?
So they're saying that there's 8 ways to choose one of the 4 sides, and then choose. So like you have to choose one side to start, and then choose um there's the next 3 sides remaining you have to choose from, and then you have to like choose 4 in total. Like you have to choose one of the adjacent sides. So
Alright. There are 8 ways to choose adjacent sides to be not chosen. After picking one such set, there are 7 additional positions into which these sides can be rotated. Like you can just rotate the result, isn't it? Like you can get
yeah,
here S2, here S3, S4. Like you can just switch their position, right? Like maybe you can try here S1 and S2 or S3 and S4. And like here you might pick like 2 unchosen side. Here you might pick like 1 unchosen side. So if you choose one thing as a constant, you do have like 7 additional ways to be rotated. So that's what they're saying here. For each of these choices, there are 3 possible choices for the remaining unchosen sides. We know why. In the figure 1 and figure 2 and figure 3, we already explored why this will not happen. Alright. So, figure 2 and 3 give 2 of these choices. The third choice is the reflection of the figure 2 through a vertical line. Reflection of a figure 2 through a vertical line. What does it mean? Can you get figure 3 as the result of this reflection? Yes, Shana, can you follow that?
um,
So, okay, that is fine. We knew that 3 possible choices for the remaining unchosen sites. This information is also like unnecessary. That's fine. And we knew There are already 8 ways to choose it. So it's going to be 8 times of 3, which will give you 24, which means you're not going to choose, I mean, these three adjacent sides together, right?
Yeah.
Three adjacent sides unchosen. There are going to be 24 ways, right? So if you subtract, oh, we do have one more. 24 is there, 8 into 3. Oh, the rotation also we do have to calculate. If you add the rotation stuff as well, you do have 8 plus 24, which will give you 32. So 32 of them will not give you a decide quadrilateral. So for obtaining the decide quadrilateral, you're just going to subtract the not decide one from the total amount. So you just have to subtract the 32 from 70, which would give you the result is 38. So we have to give this in the form of a probability, right? Because the question is about the
Yeah.
probability. You know the formula for probability. Probability of the event upon the number of sample spaces. So it's going to be like 38 upon 70. If you simplify, you're going to get the result as 19 upon 35. Can you follow this, Shana?
Yeah.
Okay.
The answer is
Yeah, it's 19 upon 35. It's option B. Okay. Actually, I couldn't find time to go through the question number 24, but I will try anyway. What is the sum of all numbers q which can be written in the form of q is equal to a by b, where a and b are positive integers with b lesser than or equal to 10, and for which there are exactly 9 integers n that satisfy square root of q less than n less than q. Okay. I'm not sure whether it is related to the rational number. I'll just check the solution once. Sum of all the numbers q. Then q is in the form of a upon b. And b should be less than or equal to 10. And there are only going to be 19 integers which satisfies this condition. Okay. Yes, Shana, we can give a shot. Okay.
okay.
Suppose that a number q has the property that there are exactly 19. Okay, okay, got it. All right. So, what is the sum of all numbers q which can be written in the form of q is equal to a over b, where a and b are the positive integers with b lesser than or equal to 10, for which there are exactly 19 integers n that satisfy square root of q lesser than n lesser than q. Okay, we're gonna find the sum of all the numbers of this. Okay. They said q has the property that there are exactly 19 integers, which means from m to m plus 18, right? If you include m plus 1, m plus 2, I hope you are able to follow this statement. So if you include this inside the condition is lesser than q, lesser than n, lesser than, means square root of q lesser than n, lesser than q. So you just have to place these here. So that's what they have done here. So from this, you can create another condition that if you subtract the starting point and the end point, if you subtract the starting point and end point, you would be getting an integer. Square root of q is getting subtracted from the q, and you're also subtracting m plus 18 and m. So you know this m and this m will cancel out each other. You will obtain the result as 18. I'm not able to interpret this statement. They're saying because q minus root q is small as possible when q is as what? Q is as small as possible and root q is as large as possible. I'm not able to see any decreasing order because it is getting increased like m plus 1, m plus 2. It goes on like that. And when you subtract, root q is the starting point, q is the ending point. If you subtract, okay, Shana, I'll do one thing. I'll just go through this. I'll solve this problem and I'll send you the recordings. Okay, otherwise it would be a waste of time for us.
Okay.
Okay.
There's only one more left. Yeah, unfortunately.
Okay, then for today we'll wind up here. I'll
Yeah.
just solve the question number 24 and 25. I'll record it and then send it to you. Will that be fine?
Yeah.
Okay.
I just want
I'll
to
in
ask,
between. Yeah.
are we joining the meeting again or?
The meeting. No problem. We can stop here because I couldn't find time to go through the question number 24 and 25. I will
Okay.
do this and record it and send it to you later.
Yeah, I just wanted to ask if we could also have a class tomorrow at the same time because the test for the Cayley contest is on Wednesday. So
Is on Wednesday. Sure.
yeah,
No problem. No problem.
and I don't have school tomorrow, so.
Sure. No problem. We can have.
Oh, okay.
Okay, sure.